Welcome to our review on specific heat capacity. So first thing we need to understand here then is that when we're thinking about different materials, they're actually capable of holding different amounts of energy. So what we're looking at here is basically how much energy does it take to raise the temperature of that material. If we consider the difference between water and aluminium, then it actually takes more energy to raise the temperature of 1 kilogram of water than it does to raise the temperature of 1 kilogram of aluminium. So what we can see there is that water is capable of storing a greater amount of energy than aluminium. Now when we're talking about the specific heat capacity, we're referring to the amount of energy in joules that's needed to raise the temperature of 1 kilogram of the material by 1 degree Celsius. So do remember that it is the amount of energy to raise the temperature of 1 kilogram by 1 degree. And the units that specific heat capacity is given in is joules per kilogram degree Celsius. So what you'll find on page 2 of your exam booklet is the calculation that you need to use. So you don't have to memorize that calculation, you've just got to be able to use it. So don't forget, if it ever asks you about specific heat capacity, flick back to page 2, find this calculation. So we've got the energy in joules equals the mass in kilograms times by the specific heat capacity times by the temperature change in degrees Celsius. So to give you an example of the kind of question you might be asked here then, a kettle contains 1.5 kilograms of water at a temperature of 18 degrees Celsius. How much energy is needed to bring the water to the boil? Specific heat capacity of water is 4,200 joules per kilogram degree Celsius. So they will always give you the specific heat capacity in the question. They might just state it as they've done here, or it might be in the form of a table where you'll have to obviously select the correct material. So all we're going to do, look at page 2, find our equation first of all, and then substitute in the numbers. So we know that the mass of our water that we're actually changing the temperature of is 1.5 kilograms. We know the specific heat capacity is 4,200, and then the last thing we need to do is work out the temperature change. Now hopefully we remember that water boils at 100 degrees Celsius, so 100 minus 18, the starting temperature there, gives us a temperature change of 82. So it's going to be 1.5 times 4,200 times by 82. And that gives us our final answer of the energy of 516,600 joules. So if we think about the applications for this understanding of specific heat capacity of materials, then the most likely thing they're going to ask about in your exam is central heating systems. So they'd ask you about why we use water in a central heating system rather than something like oil, for example. And this is all related to the specific heat capacity. So we know that water has a high specific heat capacity, so this tells us that it can store large amounts of energy. So what we find there is if our water is storing large amounts of energy, then as it's going to travel through the central heating system, it's got lots of energy to then transfer to the surroundings to warm them up. If we were to use something with a lower specific heat capacity, then not as much energy could be stored in it, so that means that there'd be less energy to transfer to the surroundings, making it a less efficient heating system.